Hello and welcome to Crazy Math Productions. We're continuing our unit on quadratic functions, on radical expressions. Today we're going to look at graphing some quadratics. Now, in order to do that, I'd like to do a little bit of a review. Remember we had linear. Standard form was ax plus by equals c. Of course, we had our basic line. We had just your basic absolute value. Any sort of form there, and you're going to have a v. We also had our exponential functions. Say, for example, y equals 2 to the x. And now we're going to have some quadratics. Standard form of a quadratic, ax squared plus bx plus c. And instead of making a v, now you notice this has a corner. Very important that that is a corner. These are going to give you a U shape. Now the U shape could be right side up, it could be upside down. It just sort of depends. And something very important as we look through these, you're going to have a U shape. Now if you look very closely at the U shape, there's different things that can happen. If I look at the U shape right here, it almost looks linear. If I look at the U shape over here, same thing. It looks linear. What I need to be able to do is to be able to center it. And you notice now we get the nice U shape. If I go just to the side, especially the further up the side I go, then I'm going to get what appears to be linear. Now, you haven't done anything wrong necessarily if you get that linear looking shape with a quadratic. What's happened is that you've looked at the wrong perspective. You haven't centered it. You should have a center right there. So it's going to be very important that we find this spot here known as the vertex. This vertex is also going to produce something that's very important as well, and that is the line of symmetry. So you notice it's going to be the same distance on this side as it is this side. Same distance here as it is here. And of course, that's only if I found the vertex correctly. Now, that vertex is going to be x equals the opposite of b over 2a, assuming a function graph here. So this point right here, incredibly important. The axis of symmetry, and of course the x-coordinate of the graph of the vertex. Those two are going to be extremely important. We're going to need our standard form and this x equals opposite of b over 2a. Let's go ahead and get started. We're going to use a table of values, and I don't always start at 0. I'm going to expand this 1x squared plus 0x, because there's no linear term, this is referred to as a linear term, plus 0, excuse me. You notice I'm getting this from y equals ax squared plus bx plus c. So b is 0, c is 0, a is 1. And normally we would not need to write this down, but for the first time we're just trying to make sure that you understand what's going on. So x equals the opposite of b over 2a. Well, b is 0. A is 1. So x equals, well, the opposite of 0 is 0. 0 divided by 2, in this case, is 0. And so that's going to be my vertex. That's where everything is going to be centered. It's very important we double check, make sure, because this part is extremely important. So b is 0, a is 1, and that is correct. So we're going to go up 1 and up 2 from that place, that vertex, and also down 1 and down 2. So we're going to take, notice we have the expanded form. Now we're just going to use a simplified form. And instead of putting the x, I'm going to put a parentheses. I'm going to put this in its place. So 0 squared is 0. 1 squared is 1. 2 squared is 4. Put a negative 1, and remember, it's in parentheses. That's very important. That means that there are two negatives. Negative 1 times negative 1 is positive 1. And negative 2 times negative 2 is positive 4. Now, what should happen is our vertex would be the center. These should be the same distance apart. It's 1 away from 0, 1 away from 0. These should be the same as well. So literally 0, a pair of 1s, a pair of 4s. That's what should happen. We should have this nice symmetry. I'll go ahead and graph this. 0, 0. There's also going to be a line of symmetry right there. It's going to break these two halves apart. 1, 1. Negative 1, 1. 2, 4. And you notice I could just count 1, 2, 1, 2, and that gives me my other point, negative 2, 4. Now, make sure that you don't have a corner. Notice the corner was for absolute value functions, not for these. So we should go down. It should never quite be linear, so it's off. And there we have a graph. Let's try again. We're going to expand it into standard form. X equals the opposite of b, which is 0, over 2 times a, which is negative 2. X equals 0 divided by anything is still 0. Well, 0 divided by 0 is undefined, but 0 divided by anything besides 0 is 0. And we're going to go ahead and center it there. Our vertex is centered at 0. I'm going to go up 1, up 2 from that point, down 1, down 2. And we're going to plug into the sort of the simpler form. Let's plug in 2. Order of operations, extremely important that you use exponent first, then multiply. Some students get confused there since it's been a while since we've had to apply that properly. 2 squared, 4, times negative 2 is negative 8. 1 squared is 1, times negative 2 is negative 2. 0 squared is 0, times negative 2 is 0. And if things have worked out correctly, we should have that symmetry. So this should be a negative 2. This should be a negative 8. But I do want to check to make sure. Negative 2 times negative 2 is 4, times negative 2 is negative 8. So the symmetry is working. This is good news. My vertex is 0, 0. And again, that's going to also be my point of symmetry, my line of symmetry, excuse me. We're going to graph these, 0, 0, 1, negative 2, 2, negative 8. And again, because this is a line of symmetry, count 1 to the line of symmetry and 1 on the other side. 1, 2 to the line of symmetry, 1, 2 to the other side. And we'll go ahead and graph it. Try your best not to put a corner there, but a curve. That was a terrible job. I'll try that again. It probably has a few too many wiggles there, but that will work. That will do. Okay, we're going to expand this into standard form. One half x squared plus Now, you might be tempted into saying this is 2x. Well, there's no x there. This is not the linear term. This is the constant, plus 0x. So don't be fooled. b is still 0 here. Now, x equals the opposite of b, which is 0, over 2 times a. Again, except in the case of 0, 0 divided by anything is 0. So my vertex is centered at 0 again. Will it always be centered at 0? No, it will not. But in these cases, there's been no linear term. Now you notice this has a linear term. Number 5 as well will have a linear term. So they're going to move away from that vertex being 0. Go up 1, up 2, down 1, down 2, just to get a basic skeleton of the graph. And we're going to plug into the simplified version. 2 squared is 4. 1/2 of 4 minus 2. Half of 4 is 2. Minus 2 is 0. Okay, and we're going to plug in 1. 1 squared is 1. Half of 1 is a half minus 2. Different ways you could do that. You could put this over 1, find a common denominator. That'll be 1/2 minus 4 halves, which would be negative 3 halves, or negative 1 and 1/2. And we plug in 0. 0 squared is 0, times 1/2 is 0, minus 2 is negative 2. If everything's gone according to plan, we should have symmetry. This should be negative 1 and 1/2. This should be 0. Now looking at these, of the two to check, this one looks like it's probably going to be the easier one. So I'm going to plug in negative 2 and see if everything goes well. If not, I know one of two things has happened. Either my algebra has been done incorrectly, or my vertex was incorrect. Now negative 2 squared, in parentheses, negative 2 times negative 2 is 4. Half of 4 is 2, and 2 minus 2 is 0. So this is correct. This is working the way it should be. So 2, 0, 1, negative 1 and a half, 0, negative 2, negative 1, 1 and 1/2, negative 2, 0. And you see this gives me this nice U shape. This hopefully won't be too hard to draw. And that is a good quadratic curve there. That's also known as a parabola, so a parabolic curve. Okay, now this is the first time where we've had something other than 0 for the vertex. How do I know that? Because now we actually have something besides 0 for the b. So x equals the opposite of b, which is 1, over 2a. A is also 1. So this is x equals negative 1/2. So my vertex is centered at negative 1/2. Now I have some options here. I could go up 1, which would give 1/2. Go up another one, which would be 1 and 1/2. Go down 1, which is negative 1 and 1/2. And down 2, which is negative 2 1/2. However, since this is it's a half is the fraction I'm dealing with, there's a little trick that I can use to make life a little easier later on. Since it's a half, I'm going to go up initially by a half. Negative 1/2 plus a half is 0. Negative 1/2 minus a half is negative 1. Now, since again this is symmetry, I'm going to go up and down the same. I'm going to go up 1 and down 1. It's still centered at negative 1/2. We still are exhibiting the symmetry that we need, but it's going to make life a lot easier. So y equals x squared plus x plus 2 Let's plug in 1. 1 squared is 1, plus 1 plus 2. 1 plus 1 is 2, plus 2 is 4. Let's plug in 0. I always love plugging in 0. 0 squared is 0, plus 0 plus 2, so that's just 2. If everything went according to plan, this will be 2, and this will be 4. But let's double check with, say, negative 1 and see if that's the case. Negative 1 times negative 1 is 1, plus negative 1 plus 2. 1 plus negative 1 is 0, plus 2 is 2. So this is working well. Now we have to go with the fraction. Negative 1/2 times negative 1/2 is positive 1/4. Multiply the top and bottom by 2, and we get 1/4 plus negative 2/4 plus 2. 1 plus negative 2 is negative 1. And now I'm going to get a common denominator. That's going to be 7/4, or 1 3/4. And now all we have to do is graph. 1, 4, 0, 2, negative 1/2, 1 3/4, negative 1, 2, negative 2, 4. And you see that's going to give me that parabolic or quadratic curve. There we go. One last one. I'd strongly encourage you to pause the video. Try to see if you can do it on your own. Let's see how you did. X equals the opposite of b over 2a. Negative 2 divided by negative 2 is 1. So my vertex will be centered at 1. And we're going to go up 1, up 2, down 1, down 2. So we need to plug this in. Three will plug in. 3 squared is 9. There's the opposite of 9. 2 times 3 is 6. Negative 9 plus 6 is negative 3, minus 1, negative 4. Plug in 2. 2 squared is 4, opposite of 4. 2 times 2 is 4, minus 1. Negative 4 plus 4 is 0. Minus 1 is negative 1. Let's plug in 1. 1 squared is 1. Opposite of that, 2 times 1 is 2. 2 minus 1 is 1. Minus 1 again is 0. And this should be negative 1 and negative 4. Let's see if that's the case. Plug in 0. 0 squared is 0. Opposite of 0 is still 0. 0 times 2 is 0. Minus 1 is negative 1. So this is working just fine. And let's graph it. 1, 0. 2, negative 1. 0, negative 1. 3, negative 4. Negative 1, negative 4. And of course, don't forget our line of symmetry. It's just a helpful tool. And that is it. Thank you so much for watching Crazy Math Productions today.